let's just divert here just a second and think about wood as a structural material. And it's a little different than concrete and steel, and I just want to spend a little time going about giving you some baseline information about wood as an engineering material. And hopefully that helps you get a grasp of where we're at and why we do some of the things we do. This slide really came about from some consulting work I did years back, where I was asked to do an inspection of a wooden cooling tower down in Houston, Texas. And the consulting engineer on it had pulled me in, and he was literally pulling his hair out because he had a lot of experience in steel and concrete and not in wood. So he really had just a lot of questions, and I spent a lot of time with him just going over the basics of wood and wood science and wood as a material. So we'll start with that. First of all, wood is a biological material, and you know, it's sustainable, but it comes from our forests, and that could be urban forests as well as forests out in the countryside. The basic constituents of wood in its raw form are cellulose, hemicelluloses, and lignins, and there are some extractives in there, but the main load-carrying components in it are cellulose chains, and if you look down at the far bottom of that, without getting into too much detail, that's what a chemical cellulose chain is, and that's built up into fibers, and then those into layers within a fiber, and then those fibers are actually laid down in various growth rings, and that's, I'm sure, as you've all seen when you go to the lumber yard. Because of the way they're laid down and because of the way wood is, it's very anisotropic, it's very non-homogeneous, and in some cases it's very non-linear in its behavior. And as a consequence of all that, its mechanical property variation is quite high relative to steel and concrete. To give you an idea, coefficient of variation for some of those materials is what, 7–10%. For most wood, we assume that its strength properties, coefficient of variation is somewhere in the neighborhood of 15–20%. And we have to do that because we have to cover the variability of it. That's within one species or one species grouping. If we look at the entire package, we have even a greater variability. For example, and I'm sure you've all seen this, some of our oaks, wherever you are, oak trees, the wood is very dense, quite durable, and extremely strong. Conversely, if we go out and look at aspen trees, poplar they're commonly called, very low density, very not many extractives, so not very durable, and really quite low in strength. And so depending on what kind of species you got and depending on where you're at, you can get quite a bit of variability. And within a structure, you'll have a lot of people who, in some, especially these older structures, mixing and matching materials, and that can cause some real problems from a property standpoint as well as from a dimensional stability standpoint. So just one of the things we've got to deal with. It's a biological material, and it has relatively high variability. Some of the advantages of wood I want to cover. First of all, it has a very high strength to weight ratio, especially parallel to the fiber axis. Wood in a material, wood as it's grown, is strongest parallel to the fiber axis. So for our standpoint, from a practicing engineer standpoint, it's strongest along the grain or along the 2x4 or along the timber. It's weakest perpendicular to that. Some of the property ratios you'll get is almost a 15 or greater to 1 ratio between parallel to perpendicular properties, so very significant. That's why we have a lot of concern and debate over design of fasteners and how they perform because of that anisotropy of wood. But it is an excellent material from a standpoint parallel to the fibers. It has a really good record for durability and performance, especially if you look at the photo on the right-hand side. That's a very classic, iconic photo we use. The horizontal member with the nails in it is actually a large timber that survived the fire, and you can see that the steel melted in the fire. Wood does really quite well, especially heavy timber construction in high temperature environments. We get a char layer that forms. The char layer becomes a very good insulator and that insulator protects the inside core of the wood or the timber member that's left from any kind of thermal degradation. So it works really, really well in heavy timber construction and fire. If you want, there is a whole chapter on post-fire assessment in the Wood and Timber Condition Assessment Manual, very well written by one of my colleagues, Robert White. So anyway, it has a very good record for durability and performance. Especially, there is some durability differences between species, but with some of the common preservatives we use today and good design practice, you can take care of a lot of the concerns we have with durability. It's very good in insulation against heat and sound and electricity, absorbs energy quite well and dissipates it quite well. So there's a real advantage to that. It absorbs and dissipates vibration quite well, shock loads quite well. So it's a good material as far as that goes. It is not a brittle material. It behaves in most cases in a very ductile fashion. So as a consequence of that, it's very good at absorbing and dissipating energy in a variety of forms. The good part and the bad part of wood, and I'm going to show you an example of that, is very easy to modify and repair in the field. I'll show you an example of that, why I think it's a blessing and a curse. A major disadvantage with wood, and that we constantly run into, is it has issues in relationship to moisture. Because of its biological nature and the way it's formed, when water gets into wood, it causes it to swell and to move. And we've all been in buildings where we've seen, tables that are a little not level anymore, doors that have warped. Up here in the Midwest, we have floors that buckle. A lot of that has to do with the absorption or desorption of water during the various times of the year because the wood actually moves. If you go to our wood handbook and look in one of our chapters, there's a whole chapter devoted to wood moisture relationships, how it moves, how much it moves for various wood species. The other thing that you have to be concerned about with wood, and I just threw a photo up there, is as beautiful as those fruiting bodies are, they're really cool and nice, and a lot of my artist friends love them. The fact of the matter is, wood is a biological material, and it's a source of energy, and it's a source of food for various biomechanisms. For example, fungi love to eat the cellulose portion of wood. So when wood gets wet and we get water in there, it provides the necessary moisture in an oxygen-rich environment like we would have above ground. We start to see fungal growth, and I'm sure all you folks have seen that kind of thing. So one of the concerns with wood is its relationship with water. I always say that there's 3 rules with using and designing with wood. Keep it dry, don't let wood near water, and keep water and wood separate. So it's a very important thing. Now, from an inspection standpoint, and I'll show you some photos of that, the first thing I look for is any place where there's water intrusion or water interactions with wood. For fungi and these biodeterioration mechanism agents to work, they need 3 things. They need food and shelter, which is wood. They need oxygen, and they need water. So any place where those 3 things kind of interact, you'll start to see potential for biodeterioration. Now, why that's important? Biodeterioration can degrade the strength properties of wood extremely quickly and very severely. One of the common things we see is what we call brown rot decay fungi. You've probably all seen this in the field. The wood looks crumbly and it's lost mass and density. Well before it gets to that point, that fungi's got in there and it's basically eaten away the cellulose. And when it does that, it takes away the major load-carrying components of the actual cell fiber. And as a consequence, we have done studies here in the lab that will show you, and they're available on our website, that prior to weight loss, you can have a 75% strength property loss if there's decay in there prior to any visual assessment or decay thing or indicators. So when we see these types of things, we know there's a significant problem. So one of the #1 things I want you to come away with is when you get to a structure, always look around. Where's that interaction between the oxygen, the wood, and the water? Because that becomes a major issue. So, okay. So as I said before, the number one thing is keep it dry. Now, I'm going to divert here just a second. I don't have a photo of this, but to give you how an indication of how important that is, we just completed several years ago the inspection of a 2,500-year-old mummy coffin from Egypt that was solid wood. And 2,500 years, but it had been kept very dry, and it had been kept away from moisture. And long story how it came to us, but basically a large museum here in the United States wanted to display it and asked for our assessment of it. I did the inspection, and I can report that that is the best looking piece of wood I've ever seen. But it was kept dry for 2,500 years. And it's a real indication to me, and really drove home to me the importance of wood-water interactions and what can happen if you keep wood dry and manage that, and what can't happen if you don't. So anyway, we'll go on to the next one. Let's start with a little bit of the assessment procedures that we use. When I go into a building or any kind of structure, whether it's a mummy coffin or a historic ship or any kind of building, the first thing I look for is I do an overall assessment, but a couple things we really look for, and if you call in, we need from you. What species is it? And I'll go into some of these in a little more detail. That's very important because the design values we use are very, to a certain extent, are species dependent, but they're definitely species grouping dependent. So that's very important. We need to know that. We look for things like, what's the quality of the wood? What's the property of the wood? And if you get in there, I'll show you some examples of this. Things we look for are grade stamps, if there's any on there, certain visual characteristics, and from that we can get basic property information from you, or you can derive them yourself from the Wood and Timber Condition Assessment Manual. The other thing we always look for is the condition of it. That's where the condition assessment comes in. Is there any mechanical modifications to the building? I'll show you some examples of that. Any biological damage, any fire damage, any chemical damage? Has it been treated? Is it treated? If so, what's it treated with? Those kinds of things are all important when you want to come up with an assessment, overall assessment of a building. Species identification, usually that's done with a low magnification visual examination, and it's done, there are a variety of consultants. If you get on the website, on any of the websites, you can see consultants who do wood identifications. Many universities have wood science programs either in their forestry schools or their material science departments, and they'll do wood identifications for you. We can do a certain amount of those here at the laboratory. We have the largest wood collection at the laboratory, but I always recommend that if you can, get the business out to the consultants and university folks. If you need help getting those information on those, give me a call. I'll be happy to give you information on them. Usually it requires just a very small sample from one of the members, not very big. No more than an inch square. Some of them will even do it if you just send them a sliver. Most of it's done with a small hand lens at low level magnification. And I would guess most of the wood you're going to see in the United States are native to the U.S. And most of the work we do, there's a group of woods that have been used for structural applications for many years, and so it's a pretty narrow band. But they will provide you with a documentation that says, I've inspected this piece of wood and it is such and such a species. Where that's very important is, and I get a lot of calls on this, where that's very important is if there's any loss of life or any loss of limb in any of these inspections, because that will have to be used in a court of law as evidence. So what I recommend in those cases is people get 1 or 2 wood identifications, same species, just like you would get a second opinion in any kind of medical procedures you have. I recommend to get at least 2 or 3 of those. They should come back with the same recommendation and then go from there. But there's a few around, but if you need help, give me a ring. You don't have to take out the whole piece. You do not have to tear out the whole piece. You don't have to take a skill saw and cut and go wild tearing things out. Just a small piece of wood, and they'll give you a really good indication of what the species is. Quality property assessment. And again, I'm not going to go into the details on this, but basically we'll use visual grading rules to come up with the allowable design values. And what they want to look for specifically that on that on your picture there, you'll see just kind of a generic grade stamp. If you see something like that in one of those buildings and you see it on a 2x4 or 2x12, I always recommend take a photograph of it, get it back to us, because then at least we kind of know what we're dealing with. It gives us a good starting point. We work very closely with the folks at the American Wood Council and other folks, and once we get that kind of information, we can help you out really quite well. So if you see those, the things that go into one of those grade stamps that we're going to look at, this particular one, it says number 1 and better, that's the grade. That S-GRN, that means it was surfaced in a green condition. That tells us something about the wood. The very right-hand lower corner of that grade stamp gives us a species grouping, so that kind of gives us an indication of where we're at as far as the species goes. The 12 up on the top there probably is the mill number, so we could trace it back. In some, that refers to the moisture content of the wood when it went in, so that when it was constructed. And that little logo on the bottom, that's the indicator of the particular grade, the grading association, in this particular case, Western Wood Products Association. So if you get those and you call me up, that's one of the first things I'm going to ask you. Do you see any grade stamps? Do you see anything there? If so, can you give me that information? That'd be very beneficial. Because from that, it makes it a little easier to make some decisions as to what we're talking about as properties. Some of the visual characteristics you're going to want to look for, and this is really in detail in the Wood and Timber Condition Assessment Manual, visual characteristics. Are there knots there? You know, which knots are those big, darker areas that are very dense? Those are actually the limbs of the tree, and when they cut the 2x4 out of it or the lumber out of it, that comes through as a big knot. That's a big strength reduction strength reduction for that particular member. It can cause a lot of problems depending on how it's oriented within the structure and how it's loaded. So we're going to ask you that. We're going to ask you things like, what's the slope of grain? And what we're trying to get at there is those trees don't necessarily all grow straight, and when they're cut as a consequence of that and the way they're cut, the fibers do not always line up perfectly parallel to the long axis of the member. And as a consequence of that, we start to get into some problems with reductions in load carrying capacity. So that's what we refer to when we talk of slope of grain. Warp, that's how much it's moved or twisted out of plane. That's very important because it's going to tell us stuff about how much moisture this thing has seen. Has there been any moisture events? Those types of things, very important. Are there checks or splits in it? And I'll show you some examples of that where that's very important. That's specifically important on how it's loaded and where it's loaded and where the check or split is relative to that loading. In addition to that, and I'll show you a photograph of something like this that highlights this, if it's a treated large timber, the presence or absence of splits are going to be really important to how well that preservative works in protecting the internal parts of the member. The other thing is any visual evidence of decay or deterioration. Do you see any big fruiting bodies? As I said, some of my friends want me to cut those out. They're art friends, and I said, boy, that'd be great. And I said, yeah, you can have it. That's a very severe deterioration, indication of very severe deterioration and major reduction in load carrying capacity. So those things are major things you should look for in your visual assessment. Any kind of external deterioration. Now, how we do these are some of the technologies we use to, and I'll go through some of these. We look for external deterioration, visual characteristics. We look at probing techniques. I'll show you some of those. As well as we then will go through and look at internal technologies for deterioration or detecting deterioration. Simple sounding techniques, drilling and coring techniques, ultrasound or sound wave type technologies, and simple moisture meters. Those are all very good tools that you can use to get an idea of what's going on inside a wood member. Let's start off with the visual inspection. For you folks that haven't done wood inspections, I don't know what you see, but I got to tell people always look for the obvious. And I'm going to show you some photos in just a second here that show you some obvious things that you would never think would happen in the field, but they do. Things I look for: foundation failures. Is the floor level? Are there cracks in the wall? Is there settlement? One of the major things I've seen is the sleeper members that they put on concrete foundations that are wood. If they don't use treated wood material or a highly durable species in that, those will fail, and as a consequence they will deteriorate, and you'll get sloping of the building because of their failure in compression. Those are really good indicators of what's going on. Signs of distress. I'll show you some photographs of this. Any collapsed, failed members, any excessive deflection, make note of those, then follow up to see what's going on. Any missing members. Now, you may be chuckling, but I'll show you a photo of that in a second. Fruiting bodies, as I said, any kind of biological deterioration that you see, please note it and be extremely leery of any kind of those probably are significantly deteriorated. Once you start seeing fruiting bodies on it, you've got a major loss in capacity. Any sunken faces, any members that sunk, or localized surface depressions where we have one or two members sitting on top of another member, if they sink in there, that's usually an indication that there's a problem. Big things, staining or discoloration. I'll show you a photograph of that. That's usually an indication of moisture intrusion. And as we said before, if there's moisture intrusion, bells and whistles should go off in our heads that, hey, there's a potential problem here. Any plant or moss growth in any of the splits or cracks you see. When those cracks form, they're an ideal place for water to puddle and any of these biological agents to get into the wood member. And it's we'll get plant growth in there, we'll get moss growth in there, and needless to say, that's not a good thing. Those really happen a lot on timber bridges and some of our structures that are more external than internal. Any evidence of insect damage, termites, ants, I'll show you some photos of that. That's a major problem. And in addition to that, any fire damage. There's a whole chapter devoted to post-fire assessment of structures in the Condition Assessment Manual. Make note of that. That chapter is very well written, and it really goes into detail on what to look for and how to come up with allowable design values and residual capacity for members that have been exposed to fire. Let's just go over a couple of these real quick. My missing members one, I apologize for the quality of this, but it was an actual inspection I was involved with. The gentleman I was working with, a consulting engineer, we were doing some light frame construction inspection work, and he called me and asked me if this particular homeowner had decided that they wanted to take their attic area and turn it into useful space, livable space. They took a skill saw and basically cut all the webs out of their trusses. And they call us here at the laboratory, and the question to me was, is that a good thing to do? And hopefully you folks are chuckling, because that is not a good thing to do. But look for the obvious. I mean, a lot of people would overlook this simply because any of us in engineering and dealing with wood would tell you just can't do those kinds of things. But look for the obvious. Look for anything that can be done with a skill saw, and any repairs, modifications, and think of the absolute limits on that, and then go one or two standard deviations from that, and you'll probably get them. Another classic one, I throw this one in here. This is an inspection we did on a historic structure in Pennsylvania. It's some floor joists on a building that was put together in about 1865, 1870. Actually, it was the home of the first chief of the U.S. Forest Service. Anyway, we went into there, and you can see a couple things. We've got floor joists sitting on a concrete foundation, which is not a problem. It's pretty good. The problem with this is I never recommend that we cut the bottom side of a tension member to put any kind of electrical or any kind of conduits or anything in there. It's not good practice. Now, I don't have a photograph of this, but I get a lot of phone calls in. I'm sure most of you folks have dealt with the new prefabricated wood I-joists that are on the market. Great products, highly engineered. They have solid wood or laminated wood. They have an OS-oriented strand board composite flange, and top and bottom members are the either solid sawn material or laminated veneer lumber. I always tell people that the conduits should go in the flange. That's where all the prefabricated punch-outs are. And when they call in and ask me if it's okay to cut the bottom cords off those I-joists, I have to tell them that is not recommended practice. That is not a good thing to do. Again, missing members, obvious things. The great part about wood is it's easy to fix and repair. The bad thing about engineered wood is that everybody thinks they know what they're doing and they can fix or repair it. So for us in the inspection part of it, we've got to notice those things. And I don't have any specific pictures of that, but I'm sure you can all imagine what happens when you take those bottom members off a prefabricated I-joist and cut them across the whole floor system. It is just not a really good thing to do. So anyway, that's things. The other thing that I tell people to look out for, and especially when we get into treated wood products, treatments in wood have, for biodeterioration, protection, those kinds of things, have varied over the years. We've gone from creosote treated, the heavy black coal tar preservative that was used, for the last century, to pentachlorophenol, which was taken off the market, and then CCA treated, which now has been changed. A lot of those treatments have a detrimental effect on the wood, and they have a detrimental effect on metal fasteners. And so when I see treated wood and I see metal fasteners, this is a metal plate connected truss in some treated materials. When I start to see the kinds of corrosion that I'm seeing here, I really get very concerned, and I tell people to be very cautious of this. Now, it's not necessarily bad, but be cautious, because in this particular case, the fingers from that truss plate actually penetrate into the wood and are in direct contact with the preservative chemical. And usually they're salt-based. If there's moisture exposure coupled with the natural moisture that's in the wood, you can get a reaction in there that will cause significant corrosion of those fasteners and a major reduction in the load carrying capacity. The fasteners will lose either thickness or cross-section. The fingers may actually deteriorate to the point that they're no longer connected to the plate. And the chemical byproduct will actually attack the wood also. This is one class of materials that we're a little cautious on. You got to be very cautious on to make note of. Many of the preservative treatments embrittleize the wood, and especially some of the older treatments will embrittleize it to the point that they change the wood from a ductile material to a quasi-brittle material. So I always tell people be very cautious of that, and be very cautious when you're designing that when you see that. Make good note of it, and just be careful, because it's especially some of the older formulations. The newer ones, we've really tried our best to help the industry, and they've done a great job at trying to mitigate some of those issues, but there's still older material out there, and just be a little cautious of it. Now, having said that, when you do your wood identification or you look at some of those things, see if you can get a piece out. And one of the things I always recommend is have somebody take a look at it from a chemicals perspective and see what's in there, because that'll help you out too. This is a specific one I wanted to show you when we talked about two things. One are failed or collapsed members, and I want to talk to you about moisture intrusion. This came out of a building that my first inspection I was involved with was the football stadium at Washington State University. Now, Washington State University is located in an arid environment in eastern Washington. It's a Pac-10 school. I worked on this about too long ago to remember, but when I was a student. And all I can tell you is we're very fortunate that the WSU did not have a very good football team at the time, because we went in and inspected this part of the structure and it was in pretty bad shape. What you have here is some large timbers. These timbers were Douglas fir and they're treated with the preservative creosote. The center member is in compression perpendicular to the fiber axis, and you can see that the outside of it actually buckled. And if you look on the right-hand side, I think it's very illustrative of why that happened. Douglas fir is a great structural material, but it does not take preservative very well because of its cellular structure. There's some certain unique characteristics of the cell walls that will not let the preservative infiltrate very deeply. As a consequence of that, you'll just, as is shown in that schematic or that artist's rendition on the right-hand side, you'll just see an outer shell that's actually treated material. That split on the top, if those are deep enough, they'll actually penetrate down into the untreated wood. Water will migrate down in there from rain or whatever, and it makes a perfect environment for decay fungi to grow. If you look in that structure, that on the photograph on the left-hand side, that's exactly what happened on it. We did a post-mortem on it, and the inside of that particular member was completely deteriorated. All that was left was the outer shell of treated wood. And under compression, perpendicular to the fiber axis, it failed, and the outside side of that just buckled out. Excellent example of a member that's failed. When I see something like that, everything goes off and says that's probably why it happened. Definitely the load carrying capacities of this member has been compromised and it would have to be replaced or removed. The other thing that's very, very telling on this particular photograph is those members are resting on a concrete foundation, if you will, and there's nothing wrong with that in general, but when I do inspections, the first thing I look at is multiple materials, and this, because it was a football stadium, was an external application. Perfect place for water to puddle, perfect place for water to accumulate and migrate into the wood members. So you had a combination of wood, water, probably some splits and cracks. The oxygen could get in there, and as a consequence, you had some severe deterioration from fungal attack. So both of those photos and everything associated with this slide are in the Wood and Timber Condition Assessment Manual. But when you see something like that, that's probably what's happened. Be aware and note that that member, in essence, should be repaired or replaced. Another visual thing, and again I apologize, this is an older slide, but when we talk about mixing and matching materials, this is the end of a barrel arch in a laminated structure, and you see here a couple things. Number one, you see some concrete footing for support. You see big timber big bolts that were used there, so you've got steel, wood, and concrete. Over top of that, you've got flashing. Really what you have is a perfect place for biodeterioration or fungal growth to happen. If I was to design in the laboratory a perfect place to have decay happen, I'd have wood, I'd have oxygen, and I'd have a cover for it so that it would stay nice and warm and moist. And that's what this did. And as a consequence of that, the water would puddle up on the concrete, be absorbed into the end grain of the wood, migrate its way up, and because it never really had a chance to dry out, was kept in the sunshine in a nice warm environment, we had deterioration and decay happening in there. So what I always recommend, if at all possible, for these types of things from an inspection standpoint, can you remove the flashing? Can you remove some of these things and actually get in there and take a look at it? Because Again, when we've got different materials and we've got access to wood, water, and moisture, we've got a potential problem. One of the things I talked about before was evidence of water damage. This is the ceiling of a building we did up in northern Wisconsin on the shores of Lake Superior. It's owned by the Red Cliff Band of the one of our native tribes, and the roof was pretty compromised. What this shows is significant water damage. And while it's mold, and it probably is not a major problem, mold is not a problem from a strength reduction standpoint, the indication that there was that much water damage and that much leakage in there prompted us to pull that roof, that's the ceiling tiles down, and to get up in there and actually look at the structural members. And as a consequence of that, that's what we did. So when I see things like that, I wanted to point out to you that it's a sign of moisture damage, it's a sign of moisture intrusion, and when you see that, be very wary and take a look at it.